Should be live. Hello, everyone. Let me know if you're already here. If you can hear me in the chat. And, well, you're hopefully responding. Let me just verify that we are live in all the right places. But if you want to verify for me, that's always great. Just let me know that you can hear me in the chat. And let me send out one reminder on the event as well. And how's it going? Let's see, we're live. Someone said, yay. Also, I'll prompt you again, but if you want to share in the chat what you're working on or what you're learning, that's always really fun to see kind of like what people are doing. I assume in the ML space, if you're here learning about fine-tuning LLMs, let me know if you have like a use case for it. We're gonna wait a minute or two just for people to join in here before we get going. I'll probably share links several times. So we're gonna go through not many slides, just a few to introduce the concepts and the libraries that we're going to be working in. If you want to just go ahead and jump straight to the code and kind of read the README, you're welcome to. The links are also in the description, but I'm going to post them in the chat as well. So if you want to jump into the code, this is the workshop link. Oops. Well, here's the link for all the workshops, and I had shared a link that goes directly to the one we want, which is this fine-tuning LoRA and QLoRA example. And I'm going to recommend that if you want to follow along during the workshop, probably open up in Google Colab and we can run it there. There are a couple ways that you can run this. So if you run in Google Colab and you RCP'd on Luma, you should have access to a Flyte cluster that's running on Union. If you didn't RCP on there and you just joined in the stream, then you probably won't have access to that. But also, everything I'm going to show you today can be done in the open source, and you just need to do a little bit of extra setup to set up the Flyte dev box, and I'll talk a little bit about that later. But I'm just guessing during the workshop. I've done experiments in the past, and most people run it when I do it in Colab, and I can't run a Docker container or Docker inside Colab. So I can't do the local dev box in there. So I also don't know if everyone has access to a GPU. So the Flyte cluster that we're going to use gives you access to the GPU to actually do some fine tuning today. Also, if I sound weird, it's because I'm getting over a cold. So I apologize. I'll do the best that I can to hopefully not sound completely gross. All right, so I'll wait one more minute and then we'll get going through the slides. And I see people, someone said hello from San Diego and they can't hear us. Awesome. And then someone also said hello from Austin, Texas. So if you just joined in, like I saw a lot of people joined, say hello, let me know where you're watching from. And then I'll share this again probably several times as we go through. This is the link to the code if you want to go ahead and go on over there, but I will walk through everything that's going on. And then this is also a link to a Slack group if you want to stay in touch outside of the workshop. There's, I think it's getting up to almost 6,000 people in there. We try to post about cool AI news and some other events and stuff we do in there as well. So I'm going to go ahead and present now. And again, if you just joined, it's several slides, mostly just on the concepts and the libraries we're going to use. And then we'll go into the code and you can follow along or just watch me. But definitely ask questions as we go too. I will try to keep the flow going pretty fast through the slides. So if I don't get to them during this section, I will try to get to them later. So feel free to post stuff in the chat. It's always way more fun for me, probably everyone else too. More people are talking in there. But yeah, I'll go through the slides now. So this is the workshop on fine-tuning LLMs with LoRA and QLoRA, and we'll talk about what that is in a little bit. Just a tiny bit about me, and then also, again, a prompt to tell us about you in the chat. My name is Sage Elliott. I'm an AI engineer at Union, and I'm streaming from Seattle. So I think it's always fun to see where people are tuning in from. I'm in Seattle, and then I also run an AI book club where we read a new book every month. This has been really fun, so you can connect with me if you want to learn more about that. And then I have a background working in computer vision, ML monitoring and evaluation, ML ops, and then also a little bit of a former career in hardware engineering. And sometimes I combine that a little bit with robotics, and that's something I want to do more of this year. So if you're interested in that kind of stuff too, let me know. It's always really fun talking with other people in robotics. And again, let me know in the chat what you're working on, or what you're interested in, like, or what you're learning, or what you're interested in. And then, so LLM fine tuning, why do you need it? You probably already have a hunch if you're here, like why you might need this. But most of those LLMs that you've probably used, they're trained on general data, not your domain. They might not have your specific tone, or even have the capability to do your task. If you're using very large models, you can often kind of get around this with prompt engineering and like RAG and stuff like that, where you bring context in. But it doesn't always solve the problem. And often you might want to use in production like a much smaller model, where you don't need all this world's knowledge. You just need knowledge of the task that you're trying to do. And you can often use a small model and then train it on a specific data set, and then you're going to have it do pretty good, like just as good, or maybe sometimes even better than one of those larger models. So it helps the model on a specific task, like content analysis would be an example. Customer support's a big one. So if you have like a lot of tickets and a lot of like logs of how you reply to things, you're hopefully going to already have a really good data set for that. And then also specific domains, so that you might train this specifically on biology or healthcare. Again, if you have a large data set, like in your company or in your field, you could take one of these models and then hopefully format the data set in a way where you can fine tune a model, and then maybe have it perform even better than one of the foundation models at hopefully like a fraction of the cost. And also, like, if you want to reinforce safe, compliant, and just really have the desired outputs for your applications. And then also another thing that you're going to see probably coming up is agent tool and function calling, which now a lot of the models already come fine-tuned for this, even the small ones. But if they're not, you can fine-tune it. And then also you can use a small model to actually potentially run all your agent tasks. Again, maybe at like a fraction of cost if you had a much larger model deployed. So what is LoRA? There's also a link to the official paper. See, I think it should copy out of there. LoRA is a low rank adaptation, and it kind of works by you add a trainable smaller matrix to the attention layers in your LM. So you're actually not training. So if you did full fine tuning, you're like updating all these weights of your large language model. With LoRA, you have these kind of adapters that you add off to the side that are linked to the attention layers. And then you just train these much smaller matrices. So it allows you, if you don't have a giant GPU, like if it's a big large language model, if you don't have the GPU that can load all that in and update the weights, because that can be really computationally expensive, you can use LoRA, which gives you these smaller parameters. But you can often get really, really good results just by updating these matrices versus updating the entire model weights. So there's just kind of example, like you get embedding that comes in. This shows then like some English being responded here. Like you're going to train the adapter in this case on like healthcare. Maybe the original model didn't have that, and then it can add that context in on the output basically. And then what is QLoRA? So the Q just stands for quantized. So it's the same as LoRA, except for you're loading in a quantized version of the model into your GPU. So if you don't have the GPU that you can load that entire model into at all, you can use a quantized version, which means smaller. So you're basically just shrinking down the floating point numbers that it computes by. And this will save a lot of memory space. But usually when you do that, the model performance degrades a lot too. But again, if you don't have any other options, this might be a really good outcome where you can then still train inside of whatever GPU that you have. And a quick note on this. So you can train this LoRA adapter, and you have this original model. You can actually swap out these adapters later. So in our use case in the code today, we're going to merge them back together and deploy it. But you can actually deploy just this model weights, and then you can have this adapter layer, and then you could like swap them out in production pretty easily. And same with the quantized or the QLoRA version. So again, the LoRA part's the same. We just have the smaller model. And then so for the example today, we're also going to take this LoRA that we train with the smaller model as the example, but then we're going to merge this back into the original size model. So depending on like what your infrastructure looks like, there's different ways of doing this, where you could keep the quantized version of the model and the LoRA together, or you can merge it back to the full size model if you have a GPU that can run that kind of in production. And okay, good. I did link the paper out there. And then the libraries, how we're going to implement this today. So PEFT is a library by Hugging Face. It stands for Parameter Efficient Fine Tuning. And it basically has a lot of stuff that you would use like for implementing LoRA and other different parameter efficient fine tuning things. I think one of the biggest use cases for this is LoRA in their library. And I'll link out to this if you want to check it out. Check out their docs. And you can see here's part of the code that we're going to implement today. But we just import like LoRA config from PEFT, the parameter efficient fine tuning library from Hugging Face. And then you can see that we have a couple of if statements here. We're looking because we're going to have a flag that we could say we're going to train this with LoRA or QLoRA. And then if it's going to look at this and set up our LoRA config, where we'll talk about these parameters a little bit later in the code. But these are the parameters for your LoRA. So you can have like how much impact you want the matrix to have, the size of it. So you can go smaller or bigger depending on your needs. And then the target layers, so like the attention layers in here, as well as a couple other ones. Again, we'll talk more about this when we get to the code part here. And then for quantization, we're going to use bits and bytes, which Hugging Face in their transformers library already has this bits and bytes config parameter that you can pass in to models training or to models for training. And you can check out the original bits and bytes library here. We'll be interacting with it from the transformer library though. We can pass in, like we want to load it into 4 bits, but you can do different things like 16-bit, 32 bits, probably the original size here, but you can quantize the model in different ways and different bit configuration. So 4-bit, if it was a 32-bit and you went to 4-bit, that's quite a bit smaller, but you could also go down to 16-bit and it will also be quite a bit smaller as well, or like half the size. And then we're going to implement the pipeline on Flyte, which is the open source AI orchestration tool that we maintain at Union. You can run this, so you can run Flyte on-prem or in your cloud. I'll share a link to the GitHub repo here as well. And then you're going to get this declarative infrastructure. So if you look at the code snippet here, again, we'll go more in depth when we do the code walkthrough. But this is a snippet from the actual code that we're implementing today. So we have these 2 environments that we're creating because some of it we're doing like training, like a training task inside of a whole pipeline. We need a GPU. But for the other tasks, like for just downloading the data set, we don't want to be hogging that GPU or paying for that GPU time. So we're going to create a CPU environment that just has 2 CPUs, 4 gigabytes memory. And then inside our GPU environment task, we're going to declare that we want 24 gigabytes memory and 1 GPU. So this is going to be doing the more intensive task. And then both of these are reading from this requirements.txt. You can also pass in secrets. You can also do more setup stuff like apt-get and defining specific like CUDA versions and stuff like that for installing the packages. And what this actually does is, one, the requirements part, it actually creates a Docker image with these, so it's reproducible. And then once it's built, you can rerun this workflow, and it'll like in Union or in Union, it will build the image remotely. If you run this on Flyte, you'll build the Docker image locally, but then push it up. So it'll manage all your Docker files. Every task by default runs like in a Docker container. And then you also manage the compute specifically that you want for that task, which is really nice. And then you'll also see you get versioning, caching. So we'll like cache the download dataset step. So every time you rerun the pipeline, it won't download it again. It'll already be there. And then it's in pure Python. So you don't have any DSL to work around or anything like that to get started. And again, for people just joining, if you want to follow along, this is the link to the code repo. And I'll open up the code repo and follow along with you real quick. I was just going to show what the interface looks like while you're opening that up. So this is the pipeline, the training pipeline that we're going to build today. We have this prepare data step. Like I mentioned, this actually gets cached. We have our training. If we click into the UI, this is our training run kind of logged here. And this is in Union. Again, the stuff that we're doing today, you can also do in the open source Flyte. All you have to do is the pip install Flyte. Then you need Docker setup, and then you can run Flyte start dev box if you wanted to actually run this locally. But I will give you access to this remote cluster today. So we have our prepare data set, train step, and then evaluate. And all these have a report here that are embedded, which is really nice. And then every time you do this run, everything is versioned as well. So as you're adjusting different hyperparameters or comparing LoRA to QLoRA, you can actually come back and look at these runs and compare how they did versus your other hyperparameter tweaks. So I'm going to go through part of the collab with you to help you get set up. But then I'm going to actually look at the code with you in my local IDE, if that works for everyone. I think it's going to work better. But if you want to follow along, I'm going to go through collab, show you where everything is, and then talk about some of the commands that we're going to run here. So you can hit this open in collab button, and then it should open up in collab. I'll share the link directly to Google Colab, and Colab's Google's way of hosting a Jupyter notebook, but it gives you a whole like interactive environment here. So the first thing we have to do is run this setup cell, and this installs stuff specific in a way for Google Colab. So we're going to git clone that workshop repo, then we're going to change directory into that LoRA and QLoRA example, and then we're going to install the requirements and requirements.txt. And then Colab doesn't have in its environment like a keyring solution. So if you did install this locally on your own computer, like on Windows or Mac, and I think most Linux systems, you wouldn't need to install this keyrings alt, but in the headless environment here, they don't have one. So this is just going to allow us to temporarily save our auth token, basically, so that once you authenticate in, it won't be asking you over and over again. And then we're going to, once that's done, also one thing is we're going to set this terminal output to dumb. If you don't do this in Colab, sometimes it'll try to do fancy stuff with the text, and it kind of messes up how it looks from the outputs that we need from Flyte to kind of log in. So we can run this next code cell. What this does is creates a configuration file, and this basically says when we want to run our workflow, it's going to point to this domain, which is where our hosted Flyte instances today. And then this is the project. This is the domain of that project. So I have like development, production, staging, and then remote means we're going to build that Docker image remotely. And then the authentication type is headless because we're in a headless environment. So it's going to open this up in another browser tab as we authenticate. So if you ran this, you're actually ready to start running your workflows. And again, I'll walk through the code. Someone said, poor terminal. I didn't make up calling it dumb. I thought that was actually really funny. That's literally what you have to do is you say term is equal to dumb, which I don't know if that's normal convention for stuff like that, but it's not my fault. Again, I'll walk through the code that this is actually going to run here in a second. But if you ran this, and if you RCP'd on Luma, I had allowed your email to get through and actually be able to authenticate to this this Flyte cluster that we have hosted. So you should be able to run this next code cell. And then I'll probably ask you to authenticate in. Let me see if it does for me. Oops, no such command. What did I do? Stupid. I swear I just tried this. Oh, wait, am I missing some eval examples? Let me make sure. It's very likely I just did something stupid when I was trying to update something here. Oh, I'm missing an S in here, I think. That is my bad. Add an S at this num eval examples is what it's supposed to be. And then you'll get this link here. And then you click on that, you'll get this kind of authentication tab that should pop up. I don't know why it's going so slow. Maybe because I'm streaming too. Let me try clicking that again. Of course, always live demos. Okay, so I should be authenticated in. Unless, did I? Took me a long time for that first one to load. So the second one, see if that works. Oh no, what's happening? Let me stop and run this again. It's only when people are watching, I swear. Okay, authenticate in. All right, now it's working. Now it's submitting the build. So this might take, if it's your first time running the workflow, building this image might take like 5 minutes or so. Um, uh, and then you'll get a link that will link out to the actual build. You can also run this locally without, like, if you, well, you could run this on Colab as well, actually, as long as you have a GPU or some sort of accelerator to kind of fine tune the model here. You can run Flyte run local workflow.py, and then you just add this local flag here. And there's also a terminal user interface that gives you kind of a scaled down version of what we see in the interface when we go look at this run. You can run this locally if you have an accelerator to fine tune a model just with this local flag. So this is really nice too. Like, Flyte and Union's basically made for like really scalable production workflows. But if you want to iterate locally, debug, maybe you run with like a smaller sample size even, and just make sure that the pipeline's working. And then you can kick off a remote production run by just kind of removing this local flag, which is cool. And then if you do install Flyte locally with the Docker image, with Docker set up as well, then you can actually start up a local version of Flyte, which will look something like this. So I have it running on DGX Spark. And then you can go in and look at your whole workflows here as well. And you just need Docker set up, and then pip install Flyte, and then you can run Flyte start dev box. And you can do what we're going to do today, but just locally on your own machine with still the whole UI and reproducibility piece. All right, I think a couple of questions, maybe errors coming in on the chat. Let me see what they are saying. Real quick, let me fix this bug that I had. Samples. So if anyone else is coming in. Oops. Let me fix. Just push that up. All right, let me see what people are running into before I walk through the code that we're actually running. So Colab is hopefully supposed to be easier to run, but clearly I made a mistake there. In fact, actually, if you remove all these and you just run this, like with this method type LoRA, or you can swap it out to QLoRA or full, it should work with all these other parameters are set by default. So if you did just delete that and run this, it should work as well. Let me see. Someone said they got an error. Exception failed to get signed URL. Did you by chance register on Luma? So if you didn't register on Luma, or if you just did, I didn't see any new RCPs come in, but if you just did a little bit before the workshop, it's potentially that you weren't added to the cluster. So it's not a serverless product or anything like that. There isn't like a sign up link for it. Union's like what people use to deploy in their production environments, like on their cloud or on-prem systems. So we don't have a serverless version. You could do Flyte, the open source version. But if you weren't RCP'd on Luma, then you probably weren't added to the cluster here, and you wouldn't be able to run this or authenticate in. So that might be why. Or if you had a different email address than what you tried to log in. Anyone else get an error who's actually running it? Or are you kind of in this phase where it's building an image right now? Otherwise, I can come back to this, but I'll start going through the code here. We'll also serve the model, by the way. So we'll train our model, but then we'll actually have it served here. And then we're training our model to generate SQL. So we're going to look at the evaluations where our model, the base model is going to be awful at it. And then by the time we fine tune our model, it's actually going to be pretty decent at writing SQL. And it's a very small parameter model. It's like 135 million parameter model. Then we're going to use the LoRA. I'm going to show how to full fine tune it, and then also do QLoRA, which is overkill for the small model, but you can swap this out basically with any other model from Hugging Face. And as long as you have the GPU for it, and you might have to adjust another parameter or something like that, you'll be able to fine tune it. Someone said they IRCP'd through Luma, but still getting the error. Well, I apologize. If it was the same email, should be working. Can anyone else confirm if they were able to run it? because I know I also even tested on my personal email and I got added in and can run it. But if anyone else can let me know. But I apologize if it's if you have a different email or something like that. Like I mentioned, that could be another one if you didn't authenticate with the same one. Otherwise, I will. If you want to message me on Slack later, I'll share the link. So if this happened with anyone else and you do want to get access to the cluster to run something later today, maybe after the workshop, feel free to message me and let me know. Oh, someone said another weird thing about password reset. Yeah, so there's some things around like I was saying, it's not a serverless product, so it's me. We have like this demo cluster and it's me trying to add you all to it. But I think there's clearly a little bit of onboarding usually works pretty good, like when I do this like one off with people. So I'm not sure, like someone said they also it worked, but then they can't reset their password and I don't think they remembered what it was. So a couple little gotchas here. I'm going to go through the code and hopefully some of you can run that if you want to. Otherwise, like I mentioned, message me on Slack if you want to be added to it later today. Or again, keep in mind the stuff that we're going to look at today. You can also do this if you set it up locally as well. If you pip like install Flyte locally. All right, so this is, by the way, if you go to Colab, you can go to this folder tab and you can see workshops is downloaded and then in tutorials. And if you go into this fine tuning LoRA one, this is all the code. You can actually double click on this and it'll open up the code file if you do want to browse it that way. You're more than welcome to. I'm going to go ahead and do it in my terminal, but this is the workflow.py that we ran. We passed those parameters into. So the first task is, well, actually, let me go to config. So I already showed this in the slides, but this is a big part of Flyte or Union. You're defining your task environment, and then basically every task runs in one of these environments that we defined. So you can define a whole bunch of different ones. This is also interesting for like agents. You can use Flyte or Union to run agents in, and you can run them in different environments. So if you have like a small language model versus an API, you can define a GPU container here, run that model in that container for like an agent, and then you get everything versioned and traceable like how we saw in our UI. You could do this for like whole agent runs versus training. So we define our GPU one. Again, we're saying task environment. We give it a name. For us, we're just starting with this Debian base, and then we're adding the requirements.txt, which if I do open that up real quick, you can see it just has like PyTorch, Flyte, parameter efficient fine tuning, some other libraries from Hugging Face, and then Fast API, because we're going to use this to deploy as well. Technically, I just had one requirements.txt. Technically, we wouldn't need this in our training environment because we're not using it until we deploy the model. And then we say the amount of compute that we want, memory, the CPUs, GPU. You can define specific GPU types as well. In our case, we're just going to say 1, and it's going to default to a T4, which is going to be fine for training the model that we have today. And it's the only GPU, I think, in this demo cluster that we're using. And then for our other tasks that we don't need a GPU, we're going to define, again, same with starting with a Debian base. But we need even less packages. So we just have 3, and that's why this image built so fast. If you ran that, if you were able to run it before, you saw this probably built in like less than a minute. Installing PyTorch and everything's going to take a little bit longer. And then we're just going to say 2 CPUs and 4 gigabytes memory. That's enough for just downloading a dataset. You can also set a Hugging Face token, but we don't need it for this workshop. So just one less thing for us to run is usually nice if you're trying to follow along. So then we go back, and now we're going to create our first task, which is just a async Python function here. The part where Flyte comes in is we define that environment. And so we say that environment.task, and then we're also enabling caching. So as long as nothing in this code changes here, every time we run the entire pipeline, it's going to cache the output of this task. So we're going to download that data set. If we rerun the entire pipeline, it'll just read in the latest version of that data set that was returned here and not download it every time. So this can be a huge thing. The data set today, I think, downloads somewhat quickly, even though it's like 78 parameter or 78 rows, which, by the way, this is the data set we're going to use. and this is the model that we're using, but you can you can swap this out for a different model. So we have that Python function, pass in the parameters. By default, it's going to just take 5,000 rows and then say 500 to do evaluations on. And then we have this Flyte directory as a return type. And this is kind of nice. So if you're not used to working with like containers, basically what happens usually is like every one of these tasks is in a container. It spins up that compute, it does something, and then it spins back down. And then so that file that you did something with, like if you download a data set, then it doesn't really exist in this next container step. So you can use something in Flyte called Flyte file or Flyte directory. And this maintains, like it downloads it, it actually stores it to a blob storage like S3 or locally. There's a blob storage that will set up for you. And then you can reference that file in the next task and it'll kind of work as if it was already there, which is really nice. Like we'll have to download it in, but it's a really, really nice way of working between containers and kind of setting up a it's not really persistent, but it feels like a persistent file between containers. We're going to give it a format to save it in. So when we read into train, it's going to be in this format. Oops. And then we're going to set the dataset dictionary to have train and eval. So when we training, we can pull in the training dataset, and when we're evaluating, we can pull in the evaluation dataset. Then we have our train task, and you can see that we hit report is equal to true, and that's what allows us to define this report here. And again, every time you run this, it's going to have a version of it, so you can come back and see like what were the hyperparameters that I used? Was this a LoRA QLoRA? All that information is going to be saved here. And then you can kind of compare these charts and the actual outcomes. We pass in the dataset directory that we had downloaded. By default, the method is LoRA that we talked about in the slides, but you can also set this to QLoRA or full, like when you call it. The amount of epochs is 3, which is what we're going to do just for the workshop. If you are able to run it, it's going to take like 30-ish minutes or something like that, probably to get to the end on LoRA. But you could do more epochs. This would probably improve our model more. Also, more data would probably improve our model more too, because we're only using 5,000 out of like the 78,000 rows. So we'll see our model starts doing pretty good, but we could probably make it way better by giving it more data and giving it a little bit more time to learn. And then some LoRA configs. We'll look at this when we get to that point. We just import some things from Hugging Face, like the supervised fine trainer method, which is what we're going to use for training. And then if we scroll down, you also see there's a little bit of HTML in here. This is what builds our report here. I also tried to break it out as much as I could, and I put some other helpers into this report helpers.py. So there's some HTML in here, but a lot of it I tried to put into another .py file to kind of make this a little bit cleaner. So then we're saying if the method was QLoRA, if you were here at the slides at the beginning, this is where that bits and bytes configuration came in. So we're from transformers, doing bits and bytes config, and then we're setting the amount of what bit we want to quantize the model down to. And then we are looking to see if it has LoRA or QLoRA. Then we're going to set the LoRA config, and we use LoRA config from transformers, pass in these parameters. So there's LoRA R, which stands for rank, and that's basically, you can think of this as the size of the matrix that we're adding in. So the higher it is, the more, like the bigger it is, and the likelihood of it learning better is higher, but then it's going to take up more memory. So you're kind of depleting, like if it's too big, then you're kind of depleting the purpose of doing LoRA. And then you have alpha, which is the scaling factor. It controls basically the impact that the rank is going to, that the adapter is going to have. And the common rule of thumb for this, and these are all hyperparameters that you can adjust, but the common rule of thumb is that I think this is basically double the size of whatever you have as your rank. And then we have these layers. These are where we want to apply these rank adapters to. A lot of times you might just see these 3 too. So you have like query, key, value. Those are all present in basically any transformer. Basically of query is what to look for like in the context that's coming in. And you have key, what each token offers to match against inside like the attention layer. And then you have value, which is what information to extract once kind of matched inside of the layer. And then there's some other ones that we're using today for this specific model. When you swap out this to be a different model, by the way, you'll have to look at what they call these things. And then again, which ones you actually want to use. It might not be all these ones that we have today. So again, it's probably almost always going to be these three, but they might have them slightly labeled differently. Like they might not have an underscore. It could just be like Q, or it could just be the letter Q. So if you are swapping this out for a different model, just keep that in mind. This might be probably the only other thing you have to change in here besides the model name itself to download. And then you have the output layer though. So this is what combines the attention results from the LoRA matrix and the full weights. And then these are the LoRA, you could update in the feed forward section. So you have the gate, which controls how much information flows through the activation function, and then the higher dimension. Let's see, I forget how to explain this. You have the up. So like you can scale up the matrix dimension and then bring it back down, which is what the up and down does. And I think this, if you scale up, it allows it again to like potentially add a richer information in the LoRA, and then you can scale it back down. And then you have dropout, so you can add some lightweight regularization to prevent overfitting. So you might have used dropout before for other deep neural networks, where basically it turns off or on certain nodes so that it doesn't always activate the same ones. It can figure out how to regularize into other nodes in the neural network. And then this also, if you're doing this as a classification task, actually, you would have to change this parameter as well. This tells the library that we're doing text generation instead of classification. So if you were fine tuning something like a BERT model, which is really fantastic, if you're doing classification on unstructured text. Like actually, if I talk to a lot of industries like healthcare, for example, and I ask like, what LLM do you have like actually in production right now? A lot of the times it's a fine-tuned BERT model. So you could do what we're doing today too for like BERT models or different types of models. And I'll probably do a different workshop on classification specifically with BERT models. I actually think it's really powerful and kind of it's not the coolest hyped thing right now, but it's actually really, really powerful and actually widely deployed. I think at least last year, BERT model was like a fine-tuned BERT model was one of the most deployed models, I think, which is really cool. Twitter, probably now they use Grok, but Twitter originally used a BERT model to do like sentiment classification on every single tweet. And so you would do that often for like if you need classification on text messages or something like that in some sort of community, it's often like a BERT model running behind the scenes. So we set up our configurations, and then we're just now getting the parameter efficient fine tune model set up with that LoRA config, passing in the model, which I think we actually pass a model string in the actual pipeline part, but this is that model that I had shared here that we're going to use today, which is this small LM2 135 parameter. Then we set up our training log, and again, this is just HTML for that nice report that we're going to get. I thought it was better to just leave that in instead of stripping it away because I'm not reusing it in somewhere else. And then we're going to set up some metrics callbacks. So when we do run our workflow, we will get this chart updating over time. In fact, is there one running? Let's see if anyone actually got one running. I guess I had one running. So as this is training, this will update live over time. You can set the refresh rate to different time intervals here. So if you do it too often, it can be kind of annoying because it's like refreshing all the time. This will show over time your training loss and our learning rate scheduler. And then we're also looking at gradient norm, which is basically how much gradients it's adjusting while it's fine tuning. So it can give you an indicator of like how hard the problem is for it. So as we can see, as this is going, hopefully our loss is going to keep going down. And again, a lot of this is just code for the chart. And then we have our evaluate. So once we train our model, go back, look at this fine-tuned one. Oops, that is build an image, not pipeline. this one, if we go to the evaluate tab here, this is our fine-tuned model with LoRA in this case. And we'll actually see this is probably a higher percentage of how much better this model got. But it says the fine-tune accuracy is 58%. The base model has 0% accuracy. So even if it was just 58, we went from 0 to 58% improvement, or getting 58% right on these 50 eval examples, which, as we'll see, is actually probably a higher percentage than this, because we're basically evaluating on, does it exactly match this expected SQL statement? But there's different ways of writing SQL that can return the same results. So this is what we were expecting when we ask, what is the name of the institution with the mascot of the Blue Devils? Question mark. So this now is trying to write SQL to query for this. So this is the ground truth result that we know is going to be good, is this: select institute from table, the table name, where mascot is equal to Blue Devils. And when you ask it this question, you also give it context of like what the table schema is, so it would know like to query this table. And you can see this is the base model, just that 135 million parameter model. It doesn't quite get there. It's generating like multiple things. Like you can see, it doesn't stop generating in the right way. Like it's adding these weird like hashtags in there. The result, it's not just the code. And I even tried to account for this in our evaluation results. We'll see in the code in a second when we go back there. But we even try to strip out just when this starts. So we look at the first result and hopefully it would do a good job. But even that, it doesn't. You can see it still classifies it as wrong, or this would be wrong because it just queries the table, but it doesn't query like where is the mascot of the Blue Devils. So this is the base model. Wrong query in general, and then also kind of rambling with like multiple queries. And then this is our fine-tuned model. It actually put the exact correct thing that we were expecting here. If we scroll down, same thing for this one. This one is wrong, or classified as wrong. We can see, because I think this would still work. We're just not getting the minimum number returned here. But I think this is still valid SQL. It's not just querying the table randomly. It's actually doing, it looks like a good query to me. If you're actually doing this in production, you might want to have a test database and then actually have the evaluation look at the result that's returned, not compare one SQL query to another SQL query. But eyeballing this, you can see that our model is actually it's doing pretty good at writing SQL, and a lot of these times it's actually is correct. And when it's wrong, it looks like it is a little bit wrong. Like in this case, this episode number should be 1 and not 2, but I think that's the only thing it got wrong here. So it's doing a decent job at writing SQL versus the unfine-tuned model, which is not doing a very good job at all. So going back to the code, we set up this evaluate task, and we read in the fine-tuned model, the data set. By default, the number is 50 here, but we could overwrite this when we call the model. If you saw in Colab, we build a report, and we're generating our SQL examples. Oh, and this is the normalized part. So like I was saying, I even tried to be generous and strip away, like stop at this characters that it was putting out, and then see if the query was right. But it wasn't at all before then anyway, like we saw. We're building a report. Again, just some a kind of a decent amount of report code here. If we keep scrolling down, the actual part is we're enumerating through the examples, and then we read in our, again, a lot of more charts here. Where's the part where we actually do our model? Oh, wait, that might have been right before we build the charts. Yeah, so we're downloading our fine-tune model here into the task, and then running the results. So each time the other enumerate was enumerating through the unfine-tuned model, and then this is going through our fine-tuned model, and then tacking the results into that report like we saw. Again, a lot of just HTML to make those reports look nice. And then we have this is basically another task, but it's a workflow, so we're calling it pipeline, and it's kind of orchestrating all those tasks together. We have those parameters that are default that we can overwrite, but this is the default model if you don't pass another one in. And this is the default data set if we don't pass another one in. Again, default method is LoRA, etc. We've kind of seen this before. If you scroll down, basically the task that we defined above, we start calling here. So we have this data directory, call it, it's going to download that data. Then we're going to pass this into our fine tune call. And we're basically just orchestrating all those three pipeline pieces here. And that's what calls them in order and how it passes data from one to the other. We define it in that task. So if you ever use Flyte v1, so Flyte's used by like thousands of companies in production. If you use Flyte v1, there used to be a decorator called workflow that you would do tasks, and then you would have a workflow decorator orchestrating those tasks together. In v2, if you haven't used it before, which is what we're using today, everything is now just a task. And so inside this task, you can call other tasks, you can do loops, you can do if statements. In v1, you couldn't do like this is pure Python. And in v1, it was mostly Python, but there was a couple of gotchas, like you couldn't do loops and if statements in your workflow with static. But now it's by default, it can change like however you need it to be. So this is what makes it good for agents now as well. Right. So I'm not sure, again, if people were having issues with the getting onto the cluster. I'll have to look at that later. Did anyone get this to run that was trying to follow along? I apologize if not. I have to look at what happened with the onboarding people to the cluster this morning, because I thought it worked, but clearly if people weren't able to get it to work, then it did not. But a couple other pieces to go through. So once we have our model trained, now we might want to actually serve that model. So we have this kind of app that we built here, has some examples. So this shows you, it says, this basically adds context to the model of like what the schema would look like for this, and then you can query it. It's like this says what product has the most orders. Hit generate, and we can see our model's actually deployed. I'll show you how to do that here in a second. But this is the SQL that it returned, which I'd have to run it to actually see, but I think this looks good. Select order ID, customer ID. These are all things actually in the table. Group by customer ID, order by count, and then descending limit 1. So that would, I think, show us the product that has the most orders. So a couple other ones you can try out here, see how it does. I can actually share this. I think this might work. Even if you're unauthenticated. I think I have authentication set to false, so you should be able to open that if you want and start querying it, see what happens. But to deploy it, if we go back and look at our Colab, the commands that we would run, we would say python serve.py, and I can show what this file looks like here in a second. But if I go ahead and run this, if I run it without giving it a run name, what it's going to do is automatically pull in the latest run that's in our pipelines here. So it would pull in the latest one here when it's done, pull in the artifact. But sometimes, like I was saying, these are all version. You might want to go back to different version with different hyperparameters, or one that was performing better than the other. So you can actually get a run ID, and that's what this like hash is here. So you just copy this, and then you can paste it in and say Python serve run name, and it's going to pull out that specific version of the model. So if I run this, it's going to serve it. It's already up. I don't want to rerun it this second just because it will probably take just a minute to deploy it. If I go back to run details and I go to this app section of Flyte, then we can see I have two things in here right now. One is this SQL generator API. So this is deploying our model in a fast API. And that looks like this in this serve.py. Not that much code here. Just a kind of a simple API, fast API app. If you used that before, we're defining our app in Flyte, give it a name, give it a description, etc., a version, and then this is kind of the Flyte part, like we saw before, for defining our task. But now we're doing this for an app, and we actually have something called Fast API App Environment. We have this also pre-built for like VLM and some other ones. We don't really need a VLM for this size of model today, SGLang as well. So if you are familiar with like deploying LLMs, we have some pre-built environments for some of the tools that you would want to use. Here we're just installing from Debian base the packages that we need to deploy our model. This looks familiar to setting up the config for running our tasks. And then we have our resources. So we want 2 CPUs, just 8 gigabytes of memory, and then 1 GPU for running this model. We have this replicas. So by default, it should be 0 to 1, and we have that set here, but you could overwrite this to be like 1 and 2 or 5. So with 0 to 1, it's going to scale down after it hasn't been used for 30 minutes. I mean, again, you can adjust this number as well. But the problem with that is it can be scaled all the way down. You're not paying any compute on it. That's awesome. But then if someone visits that model or needs that model, it's going to take a few minutes for it to spin back up. So you might have scale to 1, and then you can have replicas. Like if a whole bunch of people are using this app or model, it can actually spin up another replica of it. And then and then it will scale with like the amount of people that come to the app. And then you can see it requires auth is equal to false. So you should be able to use that URL that I shared. And then we're passing in a parameter, which in this case is that pipeline that we had created, and the type is directory. And this is getting the just direct output from the whole pipeline there. You can also target a specific task in a pipeline, but in our case, our pipeline just is outputting that model. So we're just going to take that raw basically output. We're going to give it a name model. And then we're going to just define our fast API endpoints here. So like generate is going to take in that request and then return the results that we kind of saw. And then we can build the Gradio API, which is in this app Gradio. And this builds basically this kind of simple Gradio interface here. And it links to the model. Oh, actually, even before that, if you want to test this, this might work for you in the notebook too, even if you're not authenticated in. So our model is deployed. So we should be able to run. Made some collab is annoying sometimes. Let's see. Does this work? Oh, I actually didn't test this in collab. That's why. So this runs in your terminal. If you run this curl command, let me see. Should be in the README formatted correctly anyway. I'll see if I can run this in my terminal. Yeah, so you can see this output the results like we see in the Gradio app. I have to figure out if I can format this in a way to run in Colab. I don't think you can do the multi-line type of thing by default. So again, another Colab issue here. But if you run that in terminal, you can test and see if your model is actually deployed. And then the app one just basically has a simple Gradio app that gives us that interface. Gradio is also another library by Hugging Face. They actually acquired it. Originally was separate, but allows you to build these like inputs and have outputs and pre-built components, which is really nice for building like chatbots and stuff to interact with machine learning models. All right, so I know chat's been a little quiet, and I'm not sure if people are able to run it because of the either authentication issue or collab issue. So I really apologize. If you think this is interesting, though, I encourage you to spend. It shouldn't be that much time. If you have a GPU or an accelerator, you can run this on your local machine with that Flyte, with Flyte, and then Docker setup, and then Flyte dev box, which actually have linked out in Colab. So there's different run modes inside of Flyte. So you should be able to run this code. You can also even run it, like I was saying, without Docker installed. Just have that -local flag, and this won't connect to any either local Flyte instance or external Flyte instance. It will just run this code locally. Actually, we could try. Well, if people wanted to, you could run this in Colab. You would just need to change your runtime type to have GPU resources and then add in that local flag, and it should run locally, actually. I guess I won't go through that right now unless people want to. If you also think it's interesting and you want a more personal walkthrough or like see what a POC would look like on Flyte or Union, you could book time with an engineer there. And then also just check out the Flyte repo. Well, this is also the Slack channel. So if you have questions or you want me to try onboarding you again, if you want to try that cluster out. Oh, get the actual URL. Gotta get this right. It copies in like a weird Google one sometimes. So message me on Slack if you do want to try out the cluster. Again, I apologize. Usually, like I just did this last week and worked fine. Either something I messed up on my end or something else just kind of happened during the onboarding process for it. Again, not a serverless product, so it's kind of a way for me to demo it to people, but it's not as smooth as it could be yet for me to get you onboarded. So I apologize, but hopefully you thought it was interesting. Maybe you'd want to run this locally on your own Flyte container as well. Or take what you did, and even if you just remove the Flyte pieces, I hope you learned something interesting about like using LoRA and QLoRA, right? Like you can take the part of just the LoRA piece, the QLoRA piece. You can remove the Flyte task if you don't need that for your use case as well. But even if you don't remove it, you should be able to run this all locally too with this local flag. Like this. Yes, the demo gods were not fully with me today. Happens sometimes. But let me catch up. I think there's a couple questions I didn't get to in chat. And if you have any questions, let me know. Oh, and I think even before I said the demo copies, or right at the same time, someone said, no worries, the demo gods cannot be on your side every week. I am pushing them a lot, I feel like. And they said they still appreciate the walkthrough. Yeah, apologize that you couldn't follow along. Again, you should be able to later either set up a local instance that should be pretty quick, or bug me on Slack and I can try to get you onboarded. It's weird because I tried my personal email and it worked, so kind of weird. Someone said, hi, to increase the accuracy from 58 to 68, let's say, what should be the approach? Should we fine tune config parameters or should we use more training data? In this case, for this thing, one, like I had mentioned, that if I go back to the run, I mentioned that if we look at the SQL, it actually, one, might be higher than 58% because I think it's still writing more valid SQL. It's just that we're expecting it to look exactly the same. So like, I think there was one we saw where it was, I think it would actually return the right thing. It just did it a slightly different way. And then there were ones where like, this is a little bit wrong. This needs to be 1 instead of 2. So 1 is, I think more data is always good. Like I mentioned for the example, we were just running this with 5,000 rows, but the actual data set, I believe, do I still have that open? The actual data set has 78,000 rows. So I would increase the amount of data here. That's like the number one thing is adjusting the data set probably is going to help a lot. And then 2, the amount of epochs might be something that we want to do. That's another thing very easy to look at. Like we can see it looks like it's still decreasing, or loss is decreasing. So the more this goes down in general, hopefully the better your model's getting. So you could probably train this for more than 3 epochs. So basically we only looked at our 5,000 rows 3 times and updated the parameters. So you could update this to be a higher number. Again, this is just for like kind of the demo today and something that I was hoping you could all actually run kind of within the time frame. But you would update this to like, 10 at first and see, and really you might do way more than that. And this is a really small model, by the way. So our model is just that 135 million parameter model. So to get this one to work, which actually surprisingly is working pretty well, I think, just on our kind of short training example. So I would give it more data and more epochs first. And then the other hyperparameters you might want to look at tuning are the things like if you are using LoRA, it could be like the LoRA matrix adapters. You could fine tune those. Also, because this is a pretty small model, maybe you'll try full fine tuning instead of LoRA, and you might get better results. And in fact, actually, if we look at, I forgot to show this. If we look at runs, if I go into the pipeline, I actually did full fine tuning and QLoRA. I think this is the QLoRA one. So this is the QLoRA. And what was interesting is it actually still sucked. So I think because this is already a pretty small model, and then we quantized the model, it just was having a lot of trouble learning and getting the right results here. So we can actually see the fine-tuned model of QLoRA in this case is actually pretty bad. I think it's because it's a small model and just got even smaller. So probably not QLoRA in this case. QLoRA is also just overkill for this small of a model because it can probably be read into most GPUs. But you would use QLoRA if you can't fit that model into your GPU. So if you're doing something like, what's one that doesn't have a super small one? Does Llama have a really small one? There's another one I'm trying to think of. I think Quinn has a small one, but you might use a bigger parameter one of those and then load it into memory. And if we look at our fully fine-tuned one though, which I think was maybe this one, it'll show us in the report. This was the full one, and the evaluation, the full fine-tune is actually slightly less than our LoRA, which is interesting. So it might be overfitting already on that data set potentially. So it'd be something to play around with. But I think adding more data and then more epochs, and then I would start tweaking the other parameters. But those would be the first two things I would look at. And I actually wouldn't be surprised, just on the results that we're already seeing, that if I updated to read in like that full data set and maybe a couple more epochs, this would actually probably do really well. Why is that not loading? Any other questions or comments from anybody? Anyone else see anything cool in the AI space? I know Google I/O is happening, and I'm sure I know there's like new Gemma models coming out, or sorry, Gemini models. I actually don't know if there's new Gemma models, which is like their open source versions. There are new Gemma ones. I'll be excited to see those, but they just came out with the Gemma 4 not long ago, so I'm not sure if they'll have a new one yet. And I haven't seen anything else yet, but I'm sure they're going to be releasing a lot of cool stuff today around their tooling, probably new anti-gravity stuff. I don't know if anyone else has seen anything yet. Again, if you have questions later too, join the Slack channel, ask questions there. There's also an intro channel if you want to introduce yourself like a little bit more permanently, connect with other people. And then also, if you want to stay connected. And I think someone said not at this time for more questions. Thank you. They said thank you. Yeah, thank you for joining and being active in the chat. It makes it way more fun for me. So thank you. If you do want to stay connected, ask me more questions. Those are the places to go. Otherwise, I'm going to wrap up the stream here soon because I have some other work I need to do. And again, I apologize that I don't think people were able to run the collab. So I will take a look at that. And if you do want to test it out, again, message me in one of those places. And hopefully I can get you onboarded and you could try it out. But also, again, just really, if you want to really try it out more permanently, because this is a demo cluster. So you'll have access for a little bit, but then we'll probably offboard you. So if you do want to kind of more permanently run the solution, I recommend taking a look at the Flyte OSS docs. I see people saying thank you. Yeah, again, thank you for joining. Hopefully it was interesting. Hopefully you learned something new, whether about LoRA, QLoRA, Flyte, the parameter efficient fine-tuning library from Hugging Face, and bits and bytes. So this is kind of, again, that we used here. Quick kind of crash course in them, but hopefully you can take this code and you could give it to Claude even and ask it to adjust it for your use case. But if you have a use case for fine-tuning a model, or maybe this like triggered an idea, you should take this and then try fine-tuning a model and see how it goes. All right, I'm going to end the stream. Hopefully I'll talk to some of you all later.